actually started writing the tests in collaboration with the QAs, and the QAs would verify that things were there. So things have changed throughout the time, and back in 2007, we started seeing articles around mocks and stubs. So what that means is that when you have a specific interaction with a third-party tool, let's say a database or a message queue or an endpoint that is outside your control, you don't always necessarily want to test that as part of your work. Do you need to change it again? 1 second. Sorry. It's okay. Oh, that's better.
Better?
Yeah, perfect. Okay, so you don't necessarily want to test the third-party tool as part of your work, so we introduced this idea where we would mock and stub those endpoints out, and we would actually write our tests against those mocks and stubs. And it ended up that we had this idea of a testing pyramid. Anyone seen the testing pyramid example before? This is not new for software developers, okay? See, people can catch me. If anybody messages me, you'll find out. So this is not new for software developers, okay? You've had this prior art for a long time, and you had this beat into you through solid code, clean code, code and architectures, you know, all of these different things. In infrastructure, we have YOLO'd it. It has been a bit of a mess, okay? So what we can see is that at the bottom where we have unit tests, we usually have a base of much more unit tests. And as we go up testing through the entire system, the brittleness of the tests become more, so we have less tests, but it tests end to end, outside to in through the entire way. How does the same hierarchy work in ops? So right now, it probably doesn't. Okay? You may work for a company that doesn't really have any infrastructure tests. Anybody work for a company who has infrastructure tests? You're my 4, 5, 6 favorite people. 8 favorite people, okay? I don't offer to buy beer, so you're not having a beer, but that's okay, because it's illegal. But yeah, so you can see it's much more sporadic that the infrastructure testing happens than it does in software development, but we're getting there. And we have the rise of infrastructure testing. Now, it's not a new concept. It's really not. It's been around for a long time. We've had tools like ServerSpec, Test Kitchen. We've had tools like Chef Inspec. All of these different things have been around for a while, but not many people use them as today. And what tends to happen is the normal ops testing pyramid looks like that. We have one style of test that is both brittle and lots. And it's a bit of a mess. And I'm going to suggest that we need to change that. We need to change away from having this one style of test, which usually tests after the fact. Okay, so you spin up some infrastructure, you then test that the infrastructure has been spun up correctly, and that's your test. Now, of course, if it hasn't been spun up correctly, you need to destroy it and recreate it, which is not fantastic, because the damage can already be done, depending on how quickly after you test. I'm going to suggest that we have a better testing pyramid, okay, where we actually do introduce this idea of unit tests. So we will actually be able to mock different things. Now, the reason I'm talking about this today is that this is an area that's very, very big within the tool that I use, and I'm not selling you the tool, right? We realize is that development practices need to be embedded within operations practices, and operations practices need to be embedded within development practices. Thus, we're at DevOps days, right? If this thought process didn't exist, these events would not exist either. So we're trying to help and adopt the different ways throughout the community in order to make this happen. So what we've started to do is we've started to introduce the idea of being able to mock the cloud. Okay, so wouldn't it be great if your infrastructure testing tool didn't actually need credentials on your local machine to test that the infrastructure that you're going to create is actually fit for purpose? So what I mean by that is we know the responses from Amazon, Azure, and GCP. Okay, these are well-formed API responses that you give them parameters, they will give you back parameters. We know that there's a base set of interactions that they will always respond with, okay? So required parameters will always bring back those required parameters. You pass different optional parameters and they'll bring back different things. We can mock those interactions. In our infrastructure test, we don't need to test our cloud APIs. It's pointless. They test them for us. Of course, you want to make sure that there's disaster recovery and that you can fall across to the correct different regions if something happens. But technically speaking, we shouldn't be spending all of our time creating tests that tests Amazon or Azure. Because let's be totally honest, if their API goes down, we're in a little bit more problems than being able to interact with infrastructure. So let's introduce this idea of mocking, okay? And I'll show you some examples in a second how we do that. But what has become extremely prevalent in the past few months, the past year, is embedding security tests inside our daily workflow. Now, this is the rise of DevSecOps, okay? Like, this is now a huge thing. We've had this dev and ops interaction, and we left these poor security people on the outside who we ended up hating. Well, we didn't really hate them, but they're not nice to us. But they've sort of been the thorn in our side. The security are sometimes the team that have to think rationally and stop us from doing the things that we do. So therefore, isn't it better that we start incorporating them in what we're doing? Now, there have been numerous examples in the past few years of when infrastructure has been left unsecured on the public cloud. And it's shocking, absolutely shocking. One of my favorite examples is this. Okay, there was unsecured MongoDB databases in Russia that when they actually curled and had a look, they found admin@kremlin.ru addresses on every single one of them. Now, this is both hilarious and shocking at the same time, but it does happen. Something that's a little bit more sensitive is that the Ecuadorian government actually pushed an Elasticsearch cluster live that exposed the data of all of their citizens, including 6.7 million children. Now, that is worrying, that we're in 2019, 2020, and we're still pushing this type of mistake in order to actually make it happen. A funny example is that, this is not funny, please don't take this one as funny. A funny example is in the UK, just before Christmas, they published the Queen's UK Honours List. You know, the people who get like knighthoods and like all these stupid titles behind their name. And they put their entire addresses. Somebody uploaded the spreadsheet, the Excel spreadsheet, to the internet with their public addresses. Now, that's quite funny, but at the same time, it's horrifying because there were some very high security officials on that list, and potential terrorist threats were actually detected based on the back of this. We need to be better. We just need to be better. This is bad. This is extremely bad. And then the last one, which is a real shocker, this came out like, I want to say at the start of this year. Yeah, just like at the start of January. Microsoft actually exposed 250 million customer conversations of those people who use Office 365. Okay. Now, if governments and big cloud companies are making these mistakes, then it's no wonder we're making the mistakes in our smaller companies who we don't have to go through the same security and privacy concerns. Okay? And it does happen, and if you're making the mistakes, it's fine. We're human. We do make mistakes, but we can adopt tooling and we can adopt practices that help us not make these mistakes. Security is not really our primary concern when we're developing infrastructure. I would love to say that it is, but security happens after the fact. And because it happens after the fact, we end up in situations like the ones I described above. There are many, many, many more examples. I'm going to suggest that the best testing pyramid for our infrastructure actually looks like this. Okay, where we have some unit tests, some integration tests, and an absolute boatload of security tests that go with it. Now, you do this, your security teams will start giving you hugs. Free hugs. Everyone loves a hug. Not just donuts or beer, but actual hugs. And they will be an extremely happy team if you can work with them on a day-to-day basis. Any security people in here? 1, 2 people. If your infrastructure team and your security and your application developer teams came to you and embedded their testing as part of their infrastructure, would you be happy? Yeah. There you go. You would make his life much easier. Really, you would. So let's actually look at how we can do this. Okay, I have 30 minutes to try and show some demos here. Please ask questions as we. Does anybody have any questions so far? No? Anybody just happy just to be here or to work for the day? Me. Okay, so let's write some tests, okay? Let's write some code and let's see how this works. So as I said, I'm going to use a tool called Pulumi to do this, but that's just an implementation detail. You can do this using your own custom tools or whatever tools you actually use to spin up your infrastructure. Okay, so the first test is, we've got 4 different types of work, okay? And I'm going to enter presentation mode so you can actually see this. And we have like 3 different styles, and then we're adding a 4th, okay? So we have our BDD style testing, okay? So BDD is behavioral-driven development. Oh, you cannot see. Ha, I was hiding it. I see coffee, lack of coffee. We'll fix it now, it's fine. You see it? Okay, cool, better. So BDD style testing is when you say, you sort of describe it in layperson's terms that everyone can sort of read, okay? So let's go and write some BDD-style tests, okay? So I've scaffolded an application, and I'll come back and show you this part in a second. But let's like scaffold some stuff. So the first thing we're going to do is create a new folder called specs. Inside specs, we need to create what's called a spec runner. I'm going to use Mocha. I'm going to use Mocha for this. Mocha is a Node.js spec runner, which is, you can use whatever language spec runner you want. This is just for demo purposes. Okay, and in here, we're going to say Mocha test spec. And what it does is it just, it will basically crawl the directory for any files in the directory that end with .ts that isn't this file, index.ts, and it will create a Mocha spec runner for all of those files, okay? It doesn't do anything special, that code. So let's create the first one, okay, the bucket spec. Okay, so we're going to say bucket.spec.ts, and we are going to say, let's create a bucket spec. So this is a much easier way. Let's ignore these lines for the second, okay, because it's not interesting. So let's actually have a look at what it does. So we're going to describe our Amazon S3 bucket that we have created. Okay, the bucket should have an exact name of dodmad testing bucket. It should be in a specific location, so US East 1. Okay, and it should have private ACL. Of course, this is the most basic spec that you can ever imagine, but it's just to demonstrate that things can be done. So let's think about these in turn, okay? So it should have an exact name because your applications may depend on a bucket being an exact name. It should be in a specific location. US East 1 is a bad example, actually. So what we're going to do is we're going to say, we're actually going to say EU West 1 because I'm from Ireland and I'm biased. And also, we don't want to be in the UK because of Brexit. It's OK. I have an Irish passport. I'm immune. I'm immune. See, everybody in every country in Europe laughs at Brexit. So, it's great. Anyway, so we're going to say that it needs to be an EU West 1. And we're going to say #Brexit. Just to make it funny. And then lastly, it should have a private ACL. This is probably the most important part of the spec, right? Because you don't want unnecessary public buckets on the internet, because somebody, by the time you have published it, somebody has already crawled that bucket and actually indexed it and made it available to be used in different things, okay? But this location is a very interesting thing for us in Europe. Anybody have to adhere to GDPR? Yeah. And one of the things in GDPR is all about where you store your data, okay? So by default, when you create something in the cloud will have default locations chosen on your behalf as part of your account. So therefore, check that you're actually creating it in the correct location. Otherwise, you could be in some trouble. So that's one spec, okay? Let's write the next spec, okay? So let's say EKS, okay? EKS is Kubernetes in Amazon. It's a hosted service. And we're going to create eks.spec.ts. And of course, I still have code for this as well, because it would be crazy boring if you watch me type all this code. Now, it should have an approved Kubernetes version. is an interesting spec. The reason being is that security teams and database teams and all these different things sometimes don't let you use the latest and greatest versions. They don't let you use latest because your applications, one, may not be tested, and secondly, the security of it may not be tested and verified by your company. So let's check and find like actual specific versions. Ignore crappy cluster. Okay, I'll talk to you about that in a second. Okay, and then secondly, we want to make sure that it's not a publicly available Kubernetes cluster, so we want to ensure that it's not in the default VPC in Amazon. Okay, we want it to be on our own segment of Amazon's private cloud in a VPC, so we can write a spec for that as well. So let's have a look at what the actual code that we're going to be writing against looks like. So firstly, we're going to say, let's create a bucket. Okay, now the bucket looks like this. This is a declarative syntax. Anybody use Terraform? Yeah, so this is a rival to Terraform, okay? I used to work at HashiCorp on Terraform before I worked on this tool, and this is why I give demos using this tool now, because it's my company. So what we do is we say we're going to have a constant called myBucket. The bucket will be of type aws.s3.bucket, and the bucket name will be .mad testing bucket, and we'll create an ACL of public read. Okay? Anybody see any problems there straight away? Sorry? The name. Interesting. Okay. Anything else? The ACL. So immediately, because I have created these specs in advance that I need to know what I'm doing, and I'm writing some code, I know my code's going to fail, right? Demo. We want it to fail. This is one of the few demos I actually want things to fail. Okay. It doesn't happen much. And then secondly, we're going to actually add a bucket spec, and we're going to add a crappy cluster, and I'm going to tell you why it's a crappy cluster in a second. Notice there is no specified version, okay? And there is no VPC that is actually being passed to it. By default, people will create clusters that look like this, and that's okay, but it's maybe not adhering to policies within your company. And then lastly, we can create a better cluster. Oh, not that one. And it is looking like this. So first thing we do is we actually create a VPC. In Pulumi, that single line will create a VPC with a public subnet, with a private subnet, and make it available with all the routes, the route testing, and everything like that. So it's a simple one line. And you can see that I'm now passing in the VPC subnets in there. Ignore the fact that it's public. Again, this is just a demo. But the most important thing is that I'm actually specifying a version of Kubernetes that it's going to run. And then lastly, the one I want to do is I want to actually say run tests. So as part of my test spec, inside my index.ts, I expose this function called run tests. So in order to run the test as part of Pulumi, I actually just need to bring in there, and I can run it. Now, let us go, and let's make this as big as it can be for the people at the back. And I'm just ignore the fact that I'm using envchain. Envchain means that I don't give you my AWS credentials on camera, because I have done that so many times. And of course, I'm now talking about security testing, so let's not do that, okay? Let's just not do that one. But the interesting thing is we can run the command pulumi up, saying yes, and suppressing outputs. And then lastly, I want to say skip preview, just because of the fact that it'll save time in the demo. I pre-created this infrastructure. Okay, about 30 minutes ago, because it takes 25 minutes to create an EKS cluster, and I don't have that much time. So what we're actually going to do is we're going to say Pulumi up. So Pulumi is actually testing the infrastructure that was pre-created, and it's going to use our Node.js spec runner. And just around this part of the screen right here, you will actually start to see the spec tests running. If my internet, there you go. So info running, Amazon, it's just too big right now. But very soon, we will get an output of all of what is wrong with our tests. Of course, this can be a CI tool that runs this for you. This doesn't have to be run from your local machine. I'm really hoping I have internet. I do have internet, so we're OK. Any questions while we're waiting? Can we make some drawings or something? Or, there we go. Look, you can see numbers happening. They're actually running some specs. It's a little slow. I apologize. Question?
Envchain is an open source tool?
So the question is it an open source tool? It is. Yes. Everything I'm showing you right now is 100% open source. You do not need to pay for it in any way, shape, or form.
Okay. I mean, maybe later you can share
the source code?
The source code.
I will absolutely 100% share all of this source code, and I will tweet it out in the DevOps Days Madrid hashtag, okay? So we can actually see that, firstly, the program exited, okay, as a non-valid exit code because the tests failed. That's what we expected it to do. And we can actually get the full test. So first thing is it's going to run the test against the S3 bucket. Only one tick because it has an exact name as we expected, okay? But it's not an EUS1 and it doesn't have a private ACL. And then secondly, we can actually see that it will run the AKS tests, and we can see that it failed both of those because they're not there. And we get the full output of what's expected and what's not expected. So we can go and fix these tests up very quickly, or at least a couple of them. And so instead of crappy cluster in my specs right now, I can go back here and I can import a better cluster because it is a crappy cluster, and we can actually test it. And again, if I go back and run the same tests, it should be, again, it'll take a little bit of time, and we'll come back to this in a second. So you can iterate on this, okay? But of course, the infrastructure is already created, right? So if I've created a bucket in the wrong region with the wrong permissions, somebody already has details inside it. So let's change how we're doing it and do it in a slightly different way, and let's mock it, okay? So the most important thing is I want to show you first is I want to show you that I have no credentials. So I have no AWS access keys, environment variable set here, okay? So because people are like, yeah, but you must have environment variable set. I don't, I'm not cheating. It would be awesome if I could cheat and get away with it, but I can't. So here we're going to define our define our infrastructure slightly differently, okay? So we're going to define a security group. Security group will have port 22 and port 80 access that is open to the world. If you take away anything from today, please don't do that. Like literally, if you don't even care about anything I'm talking about, just don't do that one. Like really. Security people will love you if you don't. We're going to create some user data because just as a demo, we're going to create an instance, and then we're going to just set some values that we can get back from the cloud. Okay. So I'm going to create a new file called ec2 tests.js. And I'm going to do some things. The first thing I'm going to do is I'm going to mock the cloud, mock the responses from Amazon. Okay? So I can say dot, and I can say mocks. And my mocks look like this. This is a new, this is a new feature inside Pulumi that we're working with right now in order to do it. That's not the interesting thing. Is what we're basically essentially saying is when somebody requests an EC2 security group, you are going to return these values, okay? When someone is asking for an instance, you are going to return these values. Of course, any instance type has a specific type, and if you have a type, you can actually return specific default values that you know exist, okay? So it's nothing new, it's nothing crazy. It's just we don't care about interactions with Amazon, we care about the interactions within our application itself. So after we're going to do this, we're now going to introduce our specs. Okay, and I've pre-created these already. Okay, let's just remove that because that's not correct. And we're going to describe our infrastructure. Wait, what? I put it too far up the page, I apologize. So let's say mocks. There we go. And now my specs, and my specs look slightly different. Okay, so I've imported that twice. I apologize in my demo. So we can actually say, right, we're going to check the server. We're going to basically say all instances must have name tags. Okay, one of my biggest bugbears in the cloud is when people do not tag their resources because I cannot find out how much it costs, what it's actually being attributed back to, and you end up in a ridiculous scenario of, if I delete this, what is going to happen? There's numerous tweets have come out from the Pulumi corporate account where it says Stack72 has just deleted all of our development databases. And I'm like, nobody's tagged them. I'm deleting them. So anyway, and then the next one is that we can say All of our instances must not use user data. Security teams sometimes hate the fact that people can inject user data into their images because they're not images that have been blessed and images that have actually been tested. You are effectively overwriting all of the work that has been gone through about the iteration of creating proper tested machine images. Lastly, we're going to say it must have a security group. Okay? You have to give security groups. And then one after that is we must not have port 22 open to the internet because there are a lot of little bleeps out there who will try and attack your servers. They really will. Check your logs. You will find a lot of people trying to hit port 22. So we can actually run these tests. And of course, we're running these tests against this infrastructure. So the first thing we're going to see a failure right here. We're going to see a failure right here. Excuse me, this one. And we can actually see that things are actually going to be broken. So let's run the test. I have a few things that I have to do. Okay, so firstly, we're going to set, not that one. We're going to have a Node.js stack. Okay, don't worry about these two variables. These are very much Pulumi-esque implementation details that you don't need to worry about for the sake of this. But the more interesting thing is we're going to run Pulumi in test mode. What that means is it's never going to contact the cloud. And because it doesn't contact the cloud, you do not need credentials on your machine, which is a great way of actually having a fast, iterative work cycle in order to actually work. And then lastly, we're just going to use Mocha to run the file ec2tests.js. And you'll see it's extremely fast. There we go. So it's run all of those infrastructure tests in seconds, the way real testing should be. There you go, half a second. And we can start to see. So we're missing a name tag. We're using user data. OK, so let's go and fix them up. Let's actually go and make it work. So we can say tags. And we can say owner is stack72. We can remove this user data. Let's get rid of user data. And lastly, we're actually locking down port 22. And again, we can run the iteration. If this was happening in the cloud, of course, you've already created infrastructure that can be hit from the outside world. Lastly, we can see an illegal security group. What? Missing a name tag? Oh, it's not owner, it's name. And then a legal security group must name a security group. Huh? We're going to pretend that one works. I don't understand what I wrote for that. I told you, Spanish wine. So everything's there, everything's working as expected. In fact, I can go and have a look at what the code does here and see what the name security group must not have port 22 open, that's correct. Must name a security group. That's the most ridiculous spec I've ever written in my life. But anyway, it's OK. So it's fine. So we can see that we can run a ton of these tests in isolation, and there's no problem, like really. And not only that, if somebody goes and changes your infrastructure code, and they remove like your tags or set specific groups and protocols, your CI tool can be running these tests continually on check-in as part of pull requests, and you can actually see when things are broken very, very simply and very fast before it goes to production. So that's the bottom level of the pyramid as number 2 unit test. And we've created the BDD style for the second part of the pyramid, which is the integration tests, which are less. Let's go and write some security style tests, OK? Because those are much more interesting for us, and we can really see what's going on. So I have pre-created some infrastructure again, where I have some infrastructure in S3 and some infrastructure in compute. Question?
Should I wait till the end? Or?
You can shout now, please, by all means. OK, you need my help. OK, so tell me. So it means it's good. So it's good. So talk to me.
How would you see those specifications being integrated into the daily workflow?
Oh, interesting question.
Myself, I'm a developer.
Yep.
I have a Terraform, right?
Yep.
I wrote a spec with security group.
Yep.
And it's declarative, so it is what it is. There is no imperative logic in there.
OK.
So technically, I don't need to have unit tests because it's declarative. It shows me what it's going to be, right?
So good question, right? So the question is that why would I need to do this if I'm writing in a declarative syntax if you're using a tool like Terraform or so on and so forth? The question is, are you the only person that writes the infrastructure code?
Probably not. So
There you go. So there's a variable of change, the person, okay? Because if you write those specs up front in advance, people don't always go and look through testing code, right? We're developers. We do the fastest, I'm saying developers, everything, operators, developers, everything. People make the fastest change that they need to make in order to make things happen in the infrastructure, okay? But because they do that, they don't always use Terraform, or they don't always use the tooling. They have nasty little hands that go to the consoles and change them in production, okay? It's true. I have done it myself, and I've been an operator for 12 years, and I'm like, I got to get this fixed. I'll fix it in Terraform later. I've done it a ton of times, okay? But the next time then Terraform runs an up, test will fail. The test will fail. As part of your workflow, the test will fail because Terraform runs a refresh. It's going to grab the latest code. It's going to go on up, and it's going to say, wait a minute, somebody's changed a security port. Immediately, you can go and rectify that, find out who did it, okay? Beat them. Not really beat them, but beat them. Yes, it's declarative, but it's only declarative if you stop them changing it through any other avenue. If you really want your infrastructure to be declarative, take away everybody's AWS access to the console.
But how unit test changes that? I mean, if person have access to the console, how unit test going to stop it?
Well, it's not going to stop them. It's not even going to stop them in code. But it'll find it the next time you run a run because you've changed how the infrastructure is supposed to work. Yes, your Terraform code is declarative. Yes, your Pulumi code is declarative. But it is not a real representation of exactly what is in production right now.
Yeah, but then you do Terraform plan and you see the difference.
Yeah. So the test will fail. Do you always look at the output of your Terraform plan?
Yeah.
I don't. I wrote a lot of Terraform, and I still don't look at the outputs. So I really don't, because depending on how you write your infrastructure code, if you have monolithic infrastructure code that you have hundreds of resources, you could have a plan that's going on for weeks on your terminal. And to try and read the output of that is difficult. So testing is a way of actually being able to do it. I'm not advocating that you go today and you write hundreds of these unit tests. Please no. Go and write the test that makes sense for some of the core infrastructure that needs to be as secure, as locked down as you need it to be. See the other stuff that's ephemeral, that changes on a day-to-day basis? It's not worth testing. Really not worth testing. It's the same as pragmatic testing in software development terms. Test what needs to be tested. Don't just go and implement tests just to tick a box and say, I'm testing. Okay? That's what we did in software development land, and then the rise of TDD meant that when we changed stuff around, we were changing thousands of tests. Test what is imperative for your company to keep active and keep secure and keep there. Databases are a great example. If you have a long-running database, test the security groups of the database don't change. You see what I mean? So it's about being pragmatic in terms of what you test and what you don't test. The next part, security testing, test as much of it as you need to.
My question is more like, so I have a spec for development.
Yep.
Right? And I have developers accessing that spec.
Yep.
And changing it. And how do I go about distributing those specs? So would I have, for instance, security team preparing those specs and having them accessible to everyone so those specs run towards all the infrastructure? Or would it be together with the infrastructure code? Because you know how developers do.
Great question.
Test is failing.
Great question. Where do we keep the specs? We keep them with the code, right? Not only that, you run the specs as part of your check-ins. So maybe what I'll suggest here is that I don't run any infrastructure code from my laptop. I always have a central machine that runs the infrastructure code for me. Therefore, in order to get the code onto the infrastructure machine, I have to send pull requests to our repo. Our repo does all of the checks that it needs to do, including the spec testing like this. And before it's even merged, someone gets eyes on what the specs are. At that point, it's merged, and then it can run out. Of course, developers can run this from a local machine and bypass it. If that's happening in your company, that's maybe a cultural thing that needs to be addressed. I'm not saying it's a wrong thing. It's just, it's not following the flow of the process. So I very much embed my infrastructure testing and my infrastructure creation as part of a CI workflow. And that sort of circumvents what the problem that you're trying to work out where it is. So it's always, before a pull request is merged, we get the outputs of these specs into our pull request, and we can actually see there and then if somebody has broken something that they shouldn't have before it even hits any of our environments. So spec testing like this may not work in your company, and I'm not saying it needs to. I'm just saying that there is a paradigm of testing that we have to think about as part of our infrastructure. Not saying that you go and create hundreds of these in this format. Next week, they might be invalid and you might have wasted your time, but at the same time, it helps some people validate the infrastructure that they're creating before they actually create it. It gets them through the checklist of, is it open to the world? Is it secure? Can anybody steal any of my content that shouldn't be stolen, so on and so forth? And then after you've validated that that's the case, you can delete them if you want. No worries, no worries, no worries. Any other questions on it while I'm still going? Before I go off on another rant? Okay, excellent. Okay, so we have S3 infrastructure and we have compute infrastructure, and I can quickly show you what they are. So we have an S3 bucket, which has public, it has versioning enabled, it has a website. I don't know why that the website's in here. I didn't prepare this test, one of the engineering team did. And lastly, we have KMS encryption enabled on the bucket. This is not a real key. You can't steal my KMS keys. I promise it's not real. Because we want to just show that you can enable encryption on a bucket and check that encryption can be enabled on a bucket. Lastly, we have some compute where we have a VPC. It has a specific CIDR block. And then for every one of the zone IDs that inside our region, okay, so config basically goes off and says, get me all the availability zones in the region right now. For every one of the zones, I create a VPC with a specific CIDR block and with a parent. And then lastly, for every subnet, I create an instance in that subnet. We're trying to mimic a high availability architecture of like a web system or like a service that runs across multiple subnets inside a region, okay? We're just trying to show that there's a demo there. Now, we have code that goes with this. This is a new system that we're creating. Again, in Pulumi, it's called Policy as Code Crossguard. If you use Terraform, you can use Sentinel for the same style of thing, okay? So the same style of tools exist in different areas. I'm just trying to put the fact that tools are out there, use them, they're our friends. Okay, so let's go and have a look at the policy as code. So the first thing in our S3 policy as code, we can say the bucket must not be publicly accessible. Okay, Pulumi has this idea of what's called an enforcement level. So if you're trying to write some code and you want to stop it, actually creating infrastructure before it validates the policies, you can make it mandatory. If you don't make it mandatory, you can make it advisory. Let me just show you what we allow. Advisory, mandatory, or you can disable the policy if it's something that you don't care about anymore. But the most interesting thing is that being able to turn it on and off very easily. Okay, and then we can actually validate that it goes off and does everything that it does using the code. Then we must have bucket versioning enabled. We don't allow website hosting because there is like a different platform inside your company. This is any marketing people here? This is to stop those marketing people circumventing the processes, because we all allow them to do it in order to get their things done. And it does allow them to get it done, so it's okay. But if your company doesn't allow that, you can switch that one style on. And then lastly, we want to ensure that there's S3 server-side encryption enabled on the bucket to stop people stealing the details out of the bucket, okay? Because it's like quite popular in order to like scan buckets on the internet. And then we have compute rules, which basically says subnet sizing must be of a specific subnet prefix or smaller, because we run out of IP addresses quite regularly in the operations world, because we choose things like /20s all over the place when we can probably use /24s. If you don't know what that means, don't worry about it. It took me like 10 years to even know what those numbers are, and I still don't really understand them. But, and then we can say that everything must have instance tags, name tags, so that we understand the name, the business center, the cost unit, stuff like that, so we can attribute cost of systems back to people. So as part of our tests, again, we can actually run. So the first thing I need to do is export Pulumi experimental equals true. And then I can say envchain Pulumi preview, because here we're not trying to create infrastructure, we're trying to just check in advance that the infrastructure follows before it even goes through. It's like a CI style check. And we're going to pass in the policy pack directory, which will be policy as code. And I'm really hoping this works, because if it doesn't, it's going to look stupid. Just give it a second. And we'll get a full output right now of what would happen is if we tried to run and create this infrastructure. So the first thing it's doing is it's creating the stack. And now it will give us the full output that comes with it. Please, come on. Be nice to me. There we go. Excellent, excellent, excellent. So you actually get everything coming out. And these are much more like security style tests, because we're checking that encryption is enabled, versioning is enabled. You can even do things like that security groups don't have specific ingress ports or egress ports, and so on and so forth. These are much more beneficial tests than some of the other ones that I showed, but again, they're very much embedded as part of a CI pipeline, and they will run before your code runs, and it will actually give you an exit code if it doesn't actually work as expected. So what happens if you have infrastructure that currently exists that you haven't got tests for? So let's quickly write a test, okay? Let's really fast write a test. So I'm basically using Pulumi as a CLI engine here, not managing the infrastructure itself. So the first thing I'm going to do is going to say Pulumi new AWS TypeScript. I'm going to scaffold just an application folder. You don't need to worry about those details, it's fine. Name is fine, project description is fine, dev is fine. And I know I created that before in US West 2, maybe. Let me check that. Yeah, US West 2. So we're going to actually say we're deploying the infrastructure into US West 2. Okay. So all that does right now is it just creates like these files. These are the Pulumi engine files, the files that interact with Pulumi, nothing else. And we're going to go and delete them, because Pulumi doesn't create the infrastructure, it doesn't manage the infrastructure. We're just using Pulumi as a CLI driver in order to test some of our infrastructure. Okay, and again, we're going to create a folder called specs, and inside the folder, we're going to have index.ts, and in here, we're going to have mock test spec runner, and lastly, we're going to create a file called bucket.spec.ts, and in here, we're going to say our bucket spec. Okay. So that is fine. The only thing we have to do is import star as Pulumi from @Pulumi/Pulumi. No? And then we're going to do the same for AWS from Pulumi AWS. Okay. And then we just need to npm install Mocha, chai, types. You don't need to worry about those different things. There's just, they happen. And we're going to import. You know what? I'm just going to be lazy, and I'm just going to grab what it imports. There we go, that's easier. There we go. So we have some details right now. Let's just move this in here because we don't actually care about it too much. So right now we're actually saying that as part of our code, we want to go off to Amazon. So we want to say, we know that the bucket is called that, or any piece of infrastructure has this name. We want to go off to Amazon, and we want to run that bucket name, get the bucket name, and then we check that it should be in a specific location and should have a specific endpoint. And the only thing that you actually need to index or run inside your Pulumi code is run tests. Nothing else. Why you not do it? Run test, there we go. And that's it, okay? So I'm not using Pulumi to manage my code. And if I mchain Pulumi up, and let's skip the output, we'll actually see that tests are running and tests are failing. Okay, so we'll come back and we'll have a look at the output of that because I am out of time and I have 2 slides. And the slides are super easy. So well-tested code ensures that we have confidence in our changes. I have less risky deployments, okay, because we've all been in this situation where like, is it ready? Do we try it? Yeah, let's try it. Lastly, deployments can happen on a Friday. I'm not getting into that debate because there's a lot of people who are like super angry about that. And then in summary, don't just test after resources have been created. Okay? We need to test in advance because the damage may already be done. Okay? You could have leaked information already sensitive in your company. We need to ensure that our infrastructure is fit for our purpose without incurring the costs of testing that infrastructure, without bringing it up and actually able to ensure that it is. And lastly, we need to ensure that our security code doesn't have any, our infrastructure code doesn't have any security concerns. Okay? Thank you so much. I have no time for questions officially here. You can come and chat to me at the end. And there's some stickers if you want to pick up some stuff. Thank you so much and enjoy the rest of your day.